Previously, we've been looking at making probability predictions based on the standard normal distribution with the z-scores. Today we're going to be focusing on looking at normal distributions where the mean does not equal 0 and the standard deviation does not equal 1. So, if this is the case, if we have a normal distribution, but it is not a standard normal distribution, then we can use the formula here to convert our x to a corresponding z-score. The location on the density curve remains the same, which means the probability area under the density curve remains the same. Now, when we're using this calculation, we need to make sure we pay attention to our rounding rule, which for here is 2 decimal points. So let's take a look at an example of this. Let's take a problem where we have an x of 62, we have a mean for our population of 53, and we have a standard deviation for our population of 2.6. Let's use the z-score conversion formula. So plug that into your formula, process it, and then once you've got your answer, move on to the next page and let's check it together. You should have gotten 3.46. All right, notice that's if you're paying attention, making sure you're using your rounding rules appropriately. Notice, very importantly, because we've now converted our value, our x, to a z, because z distributions do not have any corresponding unit of measurement, your z-score does not have a corresponding unit of measurement. So if I've been talking about, for example, weight, and my x wasn't in pounds, then my z-score would not be in pounds. It would simply be 3.46. Now notice when we plot these onto the graph, our x of 62 is going to correspond to the same location as our z of 3.64 on the relative distributions. So our probability calculations are going to be able to be the same.